Okay, this next podcast is dealing with section 1.2 in the textbook, and that deals with grade, angle of elevation, and distance. This is just another couple ways that we can analyze and evaluate slopes and linear relations. So the first sort of concept that we come to is a grade, and this sign right here, if you can see it, is a typical example of where we would see grade used in an application. And grade, of course, is represented as a percentage, generally for hills and on road signs. Grade is essentially just a measure of slope, and it's really just evaluated or expressed as a percentage. So to find the percent grade of a steep maybe road surface or something like that, we use our slope formula, which is rise over run. But then we do one quick other step, and we times it by 100, and this gives us a percentage. Okay, so that's percent grade. It's fairly easy to do. It's fairly easy to understand. If I wanted to convert back from percent grade into slope, so for example, if I had a 20% grade and I wanted to turn that into a slope, well, then I could do the opposite. So remember, 20% is really like saying 20 over 100, which we can reduce down to 1 over 5. And that would give us a slope. So we can go back and forth between grade and slope just by understanding a few quick rules. Okay, so the next sort of concept is looking at tangents. If I'm looking at a slope of a line, then there's an angle right here that I can measure. And I can do that by finding the tangent of this angle here, which we call the angle of elevation. Okay, so imagine, if you will, this being a road surface and this being a ramp, maybe onto a truck or something. The angle here represented by this letter here, and this is the Greek letter theta, and it's, generally speaking, it is the symbol that we use for unknown angles. Okay, so an angle that we haven't calculated yet. I can do that by finding what's called the tangent of this angle. Now, to find the tangent of the angle, what I have to do, so the tangent of some unknown angle is equal to the opposite side of a triangle divided by the adjacent side of a triangle. So if we look at this triangle right here, and I'll use red pen to sort of explain it, the opposite is this side right here, right, which we also know to be the rise, and the adjacent, right, the angle or the line beside or the side beside is this side right here, which we know to be the run. So really what we're doing is we're calculating slope, and by finding the tangent of a slope, we can find this angle right here, the angle of elevation. Okay, so the tangent ratio of a slope is really just the ratio of the opposite over the adjacent. So the ratio between the opposite and the adjacent, and remember how we know it, which is the same as the relationship of the rise over the run. Okay, now the tangent ratio is really just another way to say slope, and it's another way that we can calculate slope. So if I'm given the slope of an object, I can calculate the angle of elevation of that. And also, on the other hand, if I'm just given the angle, and there's a couple examples where we are, I can figure out these sides, right? As long as I'm given one of those sides, I can figure out what the other one is, doing a little bit of algebra. Now, the other thing to sort of make mention, and we will deal with an example that deals with this, is the Pythagorean theorem. And the Pythagorean theorem can be broken down into the following formula. So a squared plus b squared equals c squared. And so if we go to a triangle, that line right here, which is our run, is representative of a squared. B squared, which is our rise, and c squared is what we call the hypotenuse, which is really just the line itself. So if I wanted to say measure how long of a board I would need for this line here, if I knew what the rise was and if I knew what the run was, I could apply this formula right here to calculate out the length of that board. Okay, so now we're going to deal with some examples where we can apply some of these principles. And so for the first example, again, it's right out of our book. Brad needs to unload a quad, places an aluminum ramp against a truck bed. So we can imagine, you know, this sort of being our truck bed, our ramp being right there. And the ramp has a slope of 7 to 40. Now remember what that means. That means that it's 7 over 40 in terms of its slope, right? Because a ratio is really just a fraction. And the question is, what is the angle of elevation? So we want to calculate that angle right there. Okay, so let's go ahead and let's solve this. To do that, well, I know that to calculate angles, I have to use the tangent, and that's equal to, remember, the opposite, or the rise, over the run. Okay, I'm given those values, right? 7 over 40 is my rise over run. So the tangent of that angle is 7 divided by 40. And so when we actually divide 7 by 40, we get the tangent of the angle is equal to 0.175. Now, if I wanted to calculate what the angle is, then I have to do what's called the inverse. Now your calculator will have this button, will have tangent, it's usually as a TAN, and then the second function of your calculator has what's called the inverse. Okay, so to do that, to find the actual angle, what you do is you take the inverse, which we will call tan -1. And remember that that's a button on your calculator, so it's not something that you have to learn to calculate. You just have to find it on your calculator. And you're going to take that of 0.175. When you take that number on your calculator, you will get an answer of about 9.9 degrees. So that means the angle here for our truck bed of elevation is 9.9 degrees on the ramp. Okay, let's look at another example. So the slope of a driveway must have a minimum angle depression of 1 degree to allow the surface water to drain away. The end of the driveway is 8 meters from the house. How many centimeters does the driveway need to drop? So we can imagine our driveway. We can imagine that we want to drop that driveway a certain amount in order to accommodate the flow of water. Okay, and so I know that this is 8 meters. And I know that I need to make this 1 degree in order for it to be up to code. Okay, so to do that, to calculate how much I need to drop, that's this. I'm going to put an X there because it's something I need to solve. I'm going to use my tangent formula again. So tangent of a line, right, of an angle is equal to the rise over the run. Now in this case, I'm given the angle. So now to calculate it, I take on my calculator and I press the tangent and I press 1, right, because that's representative of that angle, and that's equal to the rise over, and I'm given the actual run itself, which is 8 meters. Okay, so now I'm just doing some very simple algebra. So I'm taking this 8, right? And I'm timesing it by this value, right, to get rise by itself. And what I do to that side, I also do to this side. So 8 times the tangent of 1 degree is equal to my rise. And when we calculate that out, we get 0.1396 meters. Now it says how many centimeters, right? So our question is asking centimeters. So rounding that to 2 decimal places, I get 0.14 meters, and then I have to times it by 100 to get centimeters. So I'm going to get about 14 centimeters. Remember, that's my answer. So I'm going to put a box around it, and that's this angle right here. So that's how much I have to drop this driveway, 14 centimeters, in order to get a 1% grade in my driveway. Okay, last example. Josette wants to build a skateboard ramp with a 20% grade so that the top of the ramp is level with the rail. The rail is 30 centimeters high. How long does the ramp need to be? Okay, so in this case, I'm given grade. I need to, first of all, convert grade, right? So remember, 20% in terms of a grade is really like saying 20 over 100, which is equal to the rise over the run. I know that my rise is 30, so 20 over 100 is equal to, what I'm doing is I'm setting up what's called a proportion, and this will allow me to calculate this value right here, and I need to calculate this value in order to calculate the ramp, right? Because I need to actually get the ramp. So to do that, 20 over 100 is equal to my rise, which is 30, over my run. So now all I'm doing is I'm taking and I'm cross multiplying. So 100 times 30 and 20 times run. So I'm left with 20 times my run is equal to 30 times 100, or 300, and then dividing it by 20, dividing it by 20, and my run is equal to 150 centimeters. Okay, so after everything is calculated, I have 150 centimeters. So what does this mean? That means that this value is 150 centimeters. And now all I'm doing is I'm applying the Pythagorean theorem. So remember, Pythagorean theorem says that the length of the hypotenuse, or c squared, is equal to a squared plus b squared. So looking at c squared here, if I wanted to calculate what the length is, so just c, I need to take the square root of that and the square root of that. So c can be shortened up to the square root of a squared plus b squared. A squared I found to be the 150, that's squared, plus the 30, that's squared, that's b. I'm going to square root it all, and that's going to give me my length of my ramp. And when you do the math, you will get about 153 centimeters long. Okay, for this class, I want you to try the, again, the odd numbers on the building your skills, and that's the end of this podcast.